Today we are going to be talking about compound bows and the physics behind them. First of all, we're going to start this video by explaining the parts of a compound bow and what they mean to the bow. This is the stabilizer. Stabilizer helps you steady your shot as you are aiming. You can add weight right here depending on your liking of the shot. They also make something called a V-bar. It mounts right here and comes off at an angle. It accounts for the sight being mounted on the right side of the riser. Therefore, the weight going that way would counter that. Next, we're going to be talking about this sight. This sight is a 3-pin design, as you can see right there. The top pin is 20 yards, 30 yards, and then 40 yards. The neat thing about this sight, as you can see right here, has a sliding tape. When I move this tape, you can watch the entire housing move up and down. The fibers that are inside this bow light up. And the reason they light up is for this clear housing right here. The light hits those fibers, therefore making the ends of them glow. This sight also has a light right here that helps you when it's dark out in the woods or something like that, and then it will light up the fibers better for you. These are considered the limbs. The limbs flex very slightly when you draw the bow. These are the cams. To change draw length is when you pull the bow back, how far back it sits on your chin. To change the draw length, you have these little lifter tabs with all these holes that you can move, therefore moving this string right here up and down, which will change the length of the bow. These cams rotate as you draw back. To get a more aggressive poundage or draw cycle, they have different shaped cams. Some cams can come all the way out to here and have a very sharp angle coming off, therefore creating a very hard draw cycle. Therefore, the arrow is going to shoot a lot faster. This right here is a drop away rest. As the arrow stretches, or as the string is pulled back, this string will get tight and pull the rest all the way up like that. You can see the little bit of play right there. And when that's violently released, it drops down. So this is simulating when the arrow comes through and the tension from the string is released, the rest drops, getting out of the path of the flexion when the arrow comes through. Now that we know a little bit more about the bow, we're going to see it in action. The first formula we could look at is arrow speed. We could calculate this by distance divided by time equals velocity. For example, if an arrow is traveling at 300 feet every 2 seconds, that means that it is traveling at 150 feet per second.
The upward thrust of the motors is equal to the downward force of gravity. The 4 forces acting on the drone are weight, thrust, drag, and lift.
Yep. Oh.